So in the parentheses problems that's going to finish up this second, if you're left with, if you're left with, not in one word, but if you're left with a square root or an I, or both of those, the best answer has a plus or minus. If there's no square root nor I, the best answer is two numbers. In the first part of this video, the problems that don't have the parentheses, the best answer always has the plus or minus. But in the parentheses problems, I have a preference based on what happens on the right hand side. So still doing the same, square root plus or minusing square root. If the left side is something squared and the right side is a constant, this is a great way to solve. The plus or minus forces two solutions on me. On the left hand side, square rooting cancels out squares, makes it so I don't need the parentheses. And on my right hand side, that's a square root I know. I'm going to add 2 to both sides. Because that 9 doesn't have an I and it doesn't have a square root, my best answer should be 2 numbers. And how to get the 2 numbers is to make up the problems that are implied by the plus or minus sign. The 2 problems that are implied by the plus or minus sign is x equals 2 plus 9 and x equals 2 minus 9. The 2 plus 9 gives me a solution of 7. The 2 minus 9 gives me a solution of negative 7. The 2 plus 9 gives me a solution of 11. The 2 minus 9 gives me a solution of negative 7. Let me check, just to show you that I can check. The original problem is the quantity x minus 2 squared equals 81. If I wanted to check the 11, I'd make sure that 11 minus 2 squared is 81. I don't really need my calculator for that, but heck, I got it here. Plugging in 11 makes both sides reduce to 81. Similarly, if I wanted to check the negative 7, you can also confirm that it checks. And those aren't plus or minus the same number. That's why when the right side doesn't have a square root or an I, my best answer is 2 numbers, and that's what this situation was. The right side was left with no I and no square root, so my answer shouldn't have a plus or minus. It's going to be the case for 16 as well. For 16, it's set up to solve by square rooting, plus or minus square rooting. If you don't plus or minus square root, then you'll only get one solution, and these problems that have squares you should get 2 solutions. On the left hand side, the parentheses and the square cancel, the square root symbol and the square cancel each other out. And on the right hand side, I just have that memorized. You could use your calculator to do the square root of 100 and see that it's just 10. Since the right side's not left with a square root, the right side doesn't have an I, my answer shouldn't have a plus or minus sign. Should be 2 separate numbers. I'm going to solve for x by minusing 4 from both sides. If that 10 had an I or a square root, I'd stop and say I'm done. But because that 10 doesn't have an I and it doesn't have a square root, I set up the 2 problems implied by the plus or minus sign, which are going to be x equals minus 4 plus 10 and x equals minus 4 minus 10. my two separate answers are going to be 6 and negative 14. (17) and 18, a little bit uglier to solve, but not impossible. I'm going to get fraction answers. And, well, let me show you. I'll even check these. So for 18, I do square root of 3x minus 7 squared equals plus or minus the square root of 81. On the left-hand side, I get 3x minus 7. On the right-hand side, I get plus or minus 9. Since I don't, on the right-hand side, have an I or a square root, my best answer should not have a plus or minus sign. It should be two separate numbers. And there's a couple ways to solve this. Let me show you the way that I think is best for this particular problem. So I'm going to first I'm going to add 7, and then I'm going to divide by 3. On the left-hand side, I don't have a lot of flexibility in terms of how I divide by 3, but on the right-hand side, I do have flexibility. And one of my choices is to make the right-hand side into a single fraction with a 3 in the denominator, and that's actually going to make the work easier to track. So that's the choice that I'm going to use. A little bit later, I'll show you the other choice of making two small fractions on the right-hand side. Because that 9 doesn't have a square root, because that 9 doesn't have an I, my best answer should be two individual numbers that I get by separating the plus and minuses and creating two equations. The 7 plus 9 over 3 gives an answer of 16 over 3, and the 7 minus 9 over 3 gives an answer of minus 2 over 3. Neither one of those are very appealing to check minus a calculator, but with a calculator, neither one's that bad. So let me check at least one of them just to show you how to do it. If I wanted to check the 16 over 3, I'd see if 3 times 16 over 3 minus 7 squared equals 81. Turns out that those 3's cancel, and you're left with 16 minus 7 under the radical, which is just 9, and 9 squared is 81. So the reason it works is because the 3's cancel, but I don't need to be so clever right now. 3 times fraction 16 over 3 minus 7 parentheses squared gives me 81 equals to 81. And if I wanted to check the negative 2/3, I'd see if 3 times negative 2/3 minus 7 squared equals 81. So parentheses 3 times fraction negative 2 over 3 minus 7 squared, and that works as well. After this problem, we're going to get to the problems where I'm going to leave plus or minuses in my answer, because the right-hand side is going to have either an I or a square root left after I get rid of the, after I simplify the radical. On problem 20, when I square root the left-hand side, I get 5x plus 12. When I put plus or minus the square root of the right-hand side, I get 25, because the square root of 625 is 25. You should be using your calculator for, anything that you don't, anything you can't do in your head. So now I get 5x equals negative 12 plus or minus 25. And it's preferred when I go to solve this to make a big fraction on the right hand side. And I'm going to write this as x equals negative 12 plus 25 over 5. And x equals negative 12 minus 25 over 5. The first fraction comes out to be, if I'm doing it in my head right, 13 over 5. The second fraction, I believe, comes out to negative 37 over 5. So I go to write my answer for 20. I'm going to say x equals 13 over 5, comma, negative 37 over 5. Again, my answer doesn't have a plus or minus sign in it. "22 feels like the example I did. Let's do 21. So for 21, I'm going to go square root of x minus 4 squared equals plus or minus the square root of 150. Do a prime factor tree for 150. 150 equals 2 times 3 times 5 times 5. So the square root of 150 would have a 5 in front of my radical and a 2 and 3 under my radical. So this is going to give me x minus 4 equals plus or minus 5 and then rad 6, or square root of 6. I'm going to add 4 to both sides. And this is going to be considered the best answer. It would be fine if you said x equal 4 plus 5 square root of 6, comma, 4 minus 5 square root of 6. That's acceptable, but it's pointless because 4 plus 5 square root of 6 is not reducible. You can't get a 9 square root of 6. They're not like terms. And 4 minus 5 square root of 6 is equally not reducible. So those stay like that, and that up there means the same thing. Let me check one of these. Let me check, just to show you that we can, let me check x equals 4 minus 5 square root of 6. So I'd go to the original problem, change the x to 4 minus 5 square root of 6, and make sure when I do the algebra that both sides match, meaning I get a 150. So if I do 4 minus 5 square root of 6 minus 4 squared, I get a 150. That checks, and the other one with the plus is also going to check just fine. For 24, square root plus or minus square root. The left-hand side reduces to x plus 4, and the prime factoring for 20 is 2 times 2 times 5. So on the right-hand side, I'm going to get, after the plus sign, before slash outside the radical, a 2, and under the radical, a 5. And now I'm going to minus 4 from both sides, and write x equals minus 4 plus or minus 2 square root of 5, which I wouldn't make into two problems, because if I did like minus 4 plus 2 square root of 5, doesn't reduce. So this is the best answer. If the right hand side has an I or a square root, or both an I and a square root, my best answer has a plus or minus sign. 26, I'm going to do exactly my same strategy. Get x minus 3 squared under the square root equals plus or minus the square root of negative 25. The left-hand side, I'm just going to get x minus 3. And the right-hand side, I can make the negative under the square root positive if I introduce an I. And I could make the 25 into a 5. So I'm going to get x minus 3 equals plus or minus 5i. I'm going to add 5 to both sides and get x equals to 3 plus or minus 5i. I claim that's the best answer. It would be okay if I said x equals 3 plus 5i, comma 3 minus 5i. That would be okay, but not necessary. If I was in mode 2, I can go 3 plus 5 ENG button, and my calculator will show me that that can't be reduced. And so the reason I don't separate these, because that doesn't equal 8i, that doesn't equal negative 2i. Let me just check the 3 plus 5i. I won't check them both, but I'll show you that the 3 plus 5i works. Since I'm in mode 2, I can do the i's on my calculator. So I'm going to change the x to 3 plus 5i. And I'm going to attempt to show plugging in 3 plus 5i. Now that I'm in mode 2, 3 plus 5, in mode 2, ENG button ZI. So that's entering the left-hand side, and that gives me the check, at least for that one. The other answer checks the same way. I'm usually going to be in mode 1, because in mode 1 I could do prime factor trees, but for mode 2 I can do i's, but I can't do prime factor trees in mode 2. Square root of x plus 2 squared equals plus or minus the square root of negative 36. Left-hand side just becomes x plus 2. Right-hand side becomes the square root of 36 times I after the plus or minus sign. Square root of 36 is 6, so this is going to be x plus 2 equals plus or minus 6 times I, and then minus 2. For my best answer, I'm going to get x equals negative 2 plus or minus 6i, and I wouldn't make those into two separate answers because the terms aren't like terms. They can't be added or subtracted. I could check these, but I don't have to check these. Let's do 29 together. It's a little bit of ugliness. And when there's an I, there's a preferred way to write my fraction. And I'll try to show you in a bit what my calculator does if I enter the kind of a fraction that I might be inclined to enter here. There's a kind of preferred answers with i's. So I'm going to square root plus or minus square root. On the left-hand side, I just get the 5x minus 6. And on the right-hand side, I get plus or minus the square root of 75 times I. The prime factoring for 75, let me not be an idiot and write it down wrong. Make sure I'm in mode 1. 75 equals shift degrees minutes second. 75 is 3 times 5 times 5. And so I'm going to get plus or minus 5 times the square root of 3 times I. Now is where I have some flexibility. and where there's a preference on that flexibility when a problem has an I after the plus or minus sign. And it's actually kind of good flexibility to have here. So that's my step one in getting the x isolated after I've gotten rid of the square roots. It's my step two that I'm going to change up. If the right side has an I, then instead of making one big fraction on the right hand side, we generally make two small fractions. In fact, if I entered on my calculator 6 plus 5 square root of 3 times I with a big fraction, my calculator is going to make it into small fractions. I'll show you in a second when I get back into mode 2. But let me get my answer. The 5's cancel, leaves me with an x. The first fraction I'm going to write is 6 over 5. Second fraction, I'm going to cancel the 5's and get square root of 3 times I. I'm not going to make two separate answers because it has both a square root and an I. I can't enter the plus or minus on my calculator, but if I took the time to make a big fraction like I'm used to doing, and I'm in mode 2, so let me get to mode 2 to make sure I'm there. If I entered 6 plus 5 square root of 3, make sure I'm out of the square root, hit the ENG button for the I, go down to the denominator, type the number 5. When I hit equals, I get exactly that. So when I'm at the point where I need to divide to solve for x, I have my choice of making a big fraction on the right hand side or two small fractions on the right hand side. If the right hand side has an I, the two small fractions is the preferred way. Ugga. Let's do 31 together, just because I think we're getting pretty deep into the weeds here, and I want to make sure that I'm not bearing you. So maybe pause the video and try this if you're feeling, up to it. If not, this is probably harder than what I would sneak on a test. I'm still in mode 2 on my calculator, which is probably going to be a good place to be. Square root plus or minus square root. Left hand side becomes 3x plus 5. Right hand side becomes plus or minus the square root of 45 times I. If I'm in mode 2, I can't do prime factor trees. That's the cruddy thing about the way this calculator was programmed. I guess if I want a prime factor tree, mode 1, 45 equals, shift degrees, minutes, second, quote key. I get 3 times 3 times 5. So in front of my radical, after the plus or minus sign, I get a 3. Under the radical, I get a 5. And then I have the I straggling, tagging along at the end, I guess. To solve this now, I'm going to minus 5 from both sides and get 3x equals negative 5. Plus or minus 3 times the square root of 5 times I. Because the right hand side has an I, I'm going to make small fractions when I divide on the right hand side. The 3's cancel. The first fraction is negative 5/3. After the plus or minus sign, the 3's cancel, and I get square root of 5 times I. That, I'd say, is the best answer for problem 31. Maybe just two more problems. I snuck some fractions in just because some instructors like fractions. In problem 34, it's actually going to be harder to write a nice answer than I care to. So let me square root plus or minus square root. This is going to give me x minus 1/2 equals plus or minus 4. When the parentheses problems are solved, if the right side has an I or a square root, I don't get a plus or minus. If the right-hand side doesn't have an I, if the right-hand side doesn't have a square root, I shouldn't have a plus or minus. So unfortunately, I need to get rid of the plus or minus because my right-hand side doesn't have an I. Oh my gosh. Because my right-hand side doesn't have an I and my right-hand side doesn't have a square root, I need to make the separate numbers that are implied or the separate equations that are implied by the plus or minus symbol. And I only do that in the parentheses problems if that number there doesn't have an I and doesn't have a square root. Let me be lazy. First problem I needed to do was 1/2 plus 4, which is 1/2 plus 8/2, which is 9/2. Second one is 1/2 minus 8/2, which is negative 7/2. But if you can't do that, just pop some buttons out. And I'm not going to check these. I'm just going to write x equals to 9/2 and negative 7/2. But this will check. One last problem. Let us do 35 together. Oh, we're getting so long. And I'll skip 36. So for 35, I'm going to lead off with square rooting plus or minus square rooting. Obviously, I'm fatiguing here. Left side just as x plus 2/3. And on the right-hand side, 21 is not a reducible square root because the prime factoring for 21 doesn't have any squares in it. So now I'm going to add 2/3 or subtract 2/3 from both sides and get an answer that is good. But I bet you if I entered this on my calculator is going to go further. If the right-hand side has an I, two fractions are preferred. If the right-hand side doesn't have an I, like this, one fraction is preferred. Don't ask me why. But look at my calculator just did. So I'll say that this is an acceptable answer. This is actually preferred because the programmer of my calculator knows what mathematicians want to see. And how would I get there if I didn't have a calculator at my disposal? I wouldn't care if you left an answer like that. I don't have that strong preference. But to get from this negative 2/3 plus or minus the square root of 21 without a fraction, to get it to have a fraction, I'm going to write it over 1 and multiply it by 3/3. That will give me negative 2/3 plus or minus 3 square root of 21 over 3. And now that the two fractions have the same denominator, you can combine the numerators like my calculator did, leave the plus or minus sign like I forgot, and then over 3. Those are both correct. This is how we'd get from there to there by hand. And again, with i's, two separate fractions is preferred, and without i's for the square root, individual or a big fraction is preferred, but I'm not married to that. I probably wouldn't put a problem like this on a test, but just to get you exposed to some grunge, I like to maybe sneak that at the end of sections. So we just have 3 more sections to do. Chapter 6 is a really short chapter.